Hey guys, my name is Trevor Sullivan. In this video, I wanted to take a few minutes to talk to you about how you can use PowerShell to capture performance counters and metrics in the Windows operating system. Now keep in mind that this is only going to be applicable to Windows operating systems, so Windows 10, Windows Server, things like that. Unfortunately, the get counter command that we're going to be working with in PowerShell isn't available in the cross-platform version of PowerShell, which is PowerShell Core Edition. So we're going to be working in PowerShell Desktop Edition on Windows 10 here. And in front of me right now, I have Microsoft Visual Studio Code, which is an open source cross-platform editor. It's extensible. It's really nice. I like to use this for a lot of the projects that I work on. So definitely check out Microsoft Visual Studio Code. I also have a PowerShell extension installed for it that Microsoft works on. It's really good. It provides things like IntelliSense and formatting for text and debugging capabilities and code snippets and all sorts of things like that. So make sure you go out to the Visual Studio Marketplace and install the PowerShell extension. As you can see, it's up to 5.6 million downloads, so it's really popular. Definitely go check that out, as we're going to be using that today. So to get started, I wanted to start by looking at the performance monitor in Windows. And so I've got that right here in front of me now. I have basically just the percent processor time metric, which is just the default that shows up in there when you fire up Performance Monitor. And I also have added a couple of custom metrics as well that we're going to be using from PowerShell as a demonstration for the get counter command. So first of all, when you fire up Performance Monitor, to get to this screen, by the way, you can do perfmon.msc in the start run command. Just hit Windows R on your keyboard, type perfmon.msc, and you will fire up the Performance Monitor. And once you're in Performance Monitor, you're going to want to start exploring the different metrics that are available in the Windows operating system. Now, keep in mind that depending on what software is installed on your system, for example, if you have SQL Server installed, then you'll get special metrics specifically for SQL Server. Or in my case, I have Hyper-V installed, so I can get certain Hyper-V related metrics from my system. So if you're missing a certain metric, it's probably just because that particular component isn't installed on that system. So what I'm going to do is start by I'm going to right click on the background and go to Add Counters. And I'm going to take a look just at these high-level categories under Available Counters. So you can see I've got things like processor-related metrics, processor information. I've got SMB-related metrics, so I can take a look at SMB client, SMB server. I can look at TCP version 4, TCP version 6. I can take a look at, up at the top, there's a bunch of .NET related metrics. So if you're debugging or troubleshooting issues with .NET applications running on application servers like IIS servers, these .NET Common Language Runtime or CLR related metrics might actually be useful to you, just in terms of kind of figuring out what's happening within the .NET virtual machine. There's also metrics related to things like BitLocker. I haven't really explored these a whole lot, so those might reveal some interesting data. Also around Bluetooth communications and connected devices. But what we're going to do is take a look at the IPv4 and IPv6 related metrics, because this just really shows a very basic metric around the datagrams that are being sent or received per second through one of my network interfaces. So if we go ahead and choose one of these metrics, you'll see that we just get the ability to add that metric here on the right. So some of these metrics, depending on what you are looking at, will actually have specific instances. So if we take a look at network interface, for example, we look at bytes total per second, so bytes in, bytes out. You can actually see that we've got the ability to choose either all instances of that particular metric, or I can choose a specific instance of the metric. So the metric values pertaining to a specific network interface, like my wireless controller in my laptop or my wired network connection. So not all metrics are broken down into the individual instances. So in the case of IPv4 and IPv6 datagrams per second, those metrics are universal to the operating system instance, and it doesn't allow me to narrow those down to specific network interfaces. But some metrics do allow you to do that. Now, if we take a look at the processor metric here, you can see if we take a look at percent idle time, for example, or percent user time, I get this special metric instance called _total. And so that _total is actually going to be an aggregate metric across all of the 4 CPU cores that are in my system. Or you can actually get specific metrics for cores on your system. So I have, 2 physical cores, 2 hyper-threaded cores on my laptop. So I've got basically 4 logical cores, and so I can query any individual instance or all of them together using the total metric. So basically now what we're going to do is since we've just explored the metrics in Windows as a whole, we're going to switch over and look specifically at how we interact with these metrics from PowerShell. So each of these categories that you see, like process, processor, power meter, physical disk, and all those, each of these metric categories are going to be represented in PowerShell as what's called a counter set. So anytime that you see counter set, just think of these metric categories that you see in the graphical interface here. So let's go ahead and get started in Visual Studio Code here. I'm just going to go ahead and create a new file by hitting Control-N here, and I'm going to hit Control-B to minimize the sidebar just to expand the window space that I have available to me here. I'm also going to hit Control-K, Control-M, Control-KM, Control-KM, there we go. And I'm going to just type power for PowerShell and hit enter, and that's going to set the Visual Studio Code editor's context into the PowerShell context. So when you create a new file, if you look down here at the bottom right, it just says plain text, and so we want to basically tell the editor that we're working with a PowerShell script file, and that's going to enable all of the syntax highlighting features and IntelliSense and snippets and things like that. So now that we're in here, let's go ahead and hit Control-tilde. Sorry, that's actually going to invoke the wrong editor. I was actually thinking about the built-in Visual Studio Code editor, so I'm going to close my external editor there. And if you hit Control-tilde on your keyboard and you don't have any other global hotkeys in Windows like I just did, then you'll get the integrated terminal that has a PowerShell shell. Now go ahead and just do $PS version table. This is just a built-in global variable in PowerShell. And make sure that your PS edition is set to desktop. If your PS edition is set to core, then it means that you have probably configured Visual Studio Code to use PowerShell Core Edition instead of PowerShell Desktop Edition. So you'll just want to make sure that you remove that configuration. And you can do that by hitting Control-Shift-P to pull up your command palette, or F1 if you prefer. Type user settings just to open your user settings preferences here. And then click this little JSON to actually just get the raw JSON configuration here. And you might see a PowerShell related setting here. So it'd be PowerShell exe path or something like that. PowerShell.developer.PowerShell exe path. So if you have that setting in your VS Code configuration, there's a good chance that you've manually configured it to point to PowerShell Core Edition. So just make sure that you X that out, Control-Shift-K to delete that line, and save your user settings, and then reload the Visual Studio Code window. So do Control-Shift-P, reload window, and you should be good to go. Okay, so Control-tilde, bring up the console here, and now what we're going to do is call the get counter command. So this is the command that is going to allow you to search for metrics that you're interested in Windows, and also retrieve the actual counter samples or the actual metric values that we're ultimately trying to get to. So if you run get counter and take a look at the list set parameter, if you try to run the command just as is, you actually get an error because the list set parameter is actually expecting, as you can see here, a string array, so 1 or more strings. So what you can do for ease of use is just to put a star there, and that's going to list out all of the performance counter categories that we just looked at in the performance monitor tool. But that takes a little while because it actually sits there and it just enumerates all of them in the console, so I'm not going to run that. So what I'm going to do is I'm going to prefix this with IPv and then star, and then I'm going to hit F8 to run that command. And what you'll see happen here is we get back two different objects that represent the counter sets, IPv4 and IPv6, that we saw over in the performance monitor tool. Now, each of these counter sets or these categories contain individual metrics that we ultimately want to get the metric values for. So to do that, we will take a look at the individual counters under the paths property here. Now, in some case, you'll have paths with instances. So that's like in the case where you're trying to monitor a specific CPU core or monitor a specific network interface like we talked about earlier. You'll actually see paths with instances is populated. But in this case, IPv4 and IPv6 are just universal, and so they don't have specific instance paths. They just have kind of root level metrics. So let's go ahead and wrap this. Let's duplicate this command get counter. I'll do Alt-Shift down arrow to copy that line down, and then I'm going to wrap it in parentheses, and I'm going to get the .paths property from each of the counter sets that's returned by that command. So what that's going to do is it's going to kind of unwrap the arrays of the paths property on each of those counter sets, and it's going to give me a list of all of the different metrics that are available inside of those categories. So under the IPv4 category, we have datagrams per second. Under IPv6, we also have datagrams per second right here. And I'll show you a couple of techniques if you have lots of metrics and you're trying to like hunt and peck through the list, how you can actually filter that down. One way to do that is to, I'm going to do Alt-Shift down arrow to copy that line down again. I'm going to take all those strings in that array that we're getting from paths, and then I'm going to pipe them into where object, and I'm going to specify a filter script. And the filter script is basically just going to be executed once per item in that array, and it's going to evaluate and say, hey, does it match this criteria? If yes, then return it. If not, then exclude it. So in this case, I'm going to filter down to only ones that contain SEC somewhere in the name. So anything that's per second, any metrics that are per second. So I'm going to say PS item. PS item is the kind of automatic or special variable that refers to the current item in the pipeline. And then I'm going to say match SEC. So if I hit F8 on my keyboard to run that, you'll now see that we've filtered out only the metrics that have SEC in the name. If I wanted to filter down to only datagram related metrics, not and exclude all the fragment ones, I could do datagrams in my criteria, rerun that, and now I only get the datagram related metrics. So that's one way to do it, is using the where object command. I'll show you one other way to do it as well, which again is exclusive to Windows just because of its dependency on the Windows Presentation Foundation component of the .NET platform, and that's called the outGridView command. So I'm going to take all of these metric paths and pipe them into this outGridView command, and then I'm going to add this other parameter called output mode multiple. And I'll show you why in just a second. So if I hit F8 to run this current line that my cursor is on, you'll see it pops up this PowerShell window, and it actually listed out all of those metrics in this nice graphical interface. And it gives me this filter option up at the top, so I could do something like IPv4 to filter down to only IPv4 metrics, or datagrams. I can filter down to only ones that match datagrams. And so you can really type whatever you want to and narrow down specifically what you're looking for. So I'll do a little filter there, just SEC. And then what's cool is that you can actually do a control select. So I'm holding down the control key on my keyboard and selecting the individual metrics that I am interested in. And then if I hit OK, PowerShell is going to filter out just the items that I selected in that grid view dialog box, and then I can very easily copy and paste those into my script so that I don't have to hunt and peck through the really long list over here. Cool. So that's how you can kind of find the metrics that you're interested in. So now that we've kind of explored the different metric categories or counter sets and the individual metrics, let's take a look at how to actually get the counter values themselves. And we're going to use these two counters as an example. So I'm going to go ahead and copy those up into my script here. I'm going to wrap them in an array just so I can easily reference them. So I'll just create an array with 2 items and call it metrics. So I have a variable called metrics that refers to an array with 2 elements. And now what I'm going to do is call the getCounter command again, but instead of using the listSet parameter, I'm going to use the counter parameter. And as you can see, the counter parameter also takes a string array, and that's where we're going to pass in our string array of metrics. And that's going to retrieve the counter samples, or the actual values. Sorry, I have to actually run the line to define the variable, which I didn't run yet. And then I'm going to come down and hit F8 on line number 8. And now you can see I've actually retrieved the counter samples from these 2 metrics that are in this variable. So I get back this object which provides me the timestamp of my metrics, so I can feed that timestamp up to a time series database, for example. You could use something open source like InfluxDB or Prometheus, I think is another one. There's a bunch of different time series databases out there. Really, it doesn't matter where you ultimately store the data, but obviously you're going to need the timestamp because the timestamp refers to the period at which the metric values were retrieved. So under the counter samples property on this object, we have 2 items. We have the IPv4 datagrams per second and IPv6 datagrams per second. So how do we actually get to these values? Well, the first thing I'm going to do is assign the result of this command to a variable. That's going to make it a little easier to work with. So let's go ahead and just capture that in the counter variable. So now we have new values because I reran the command. And if I go to the counter samples property, I can see that I have 2 objects here. Let's go ahead and pipe this into getMember. So each of these counter sample objects are .NET performance counter sample objects. That's the class name of these objects. And you can see that we've got the actual timestamp on each of these metrics individually, as well as on the object that wraps these metric values. And we also have this property called cooked value. Now, metrics in Windows can sometimes have uncooked values and cooked values. The uncooked value just means that it has more processing to do before it's really a human readable metric, whereas cooked values are basically ready for human consumption, right? So in this case, we have datagrams per second, and whatever the cooked value is the number of datagrams per second. There's no additional processing that we have to do on that value to get some valuable meaning from it, right? So let's go back and just look at these counter sample objects. So because this is an array of counter samples, I can index into it. So I'm going to index into item number 1, or 0 in this case, index 0. And you can see this is IPv4 datagrams per second. And then I can just reference the cooked value property on array element 0. And that's the actual double value that represents the metric. So now I can take that value, I can feed that into my time series database for long-term archival, or I can just display it in a nice format inside of a script or something that runs off to the side, or maybe it just logs to a local file or something like that. But that's all I really had for this video today. I just wanted to give you guys kind of an overview of how metrics work in Windows, how you can interact with those metrics from a PowerShell session. I really hope you enjoyed this content. Please let me know in the comments what you think of this video. I'd love to hear your thoughts. I'd love to hear what other ideas you have for other types of content that you would like to learn on my channel. Also, feel free to visit my Patreon page if you would like to support this channel and help fund the development of future content. I would really love to know what else you guys would like to see on this channel. So thanks again, leave a like, and we'll see you in the next video. Cheers.